about the magnetic properties of solid and electrical properties of the solid. The magnetic properties of the different material are mainly due to the magnetic moment, which arise due to the orbital motion and spinning motion of the electron. As electron is a charged particle, its orbital motion produces a small magnetic field along the axis of the rotation, and its spinning motion produces a small magnetic field along the spin axis. Each electron can be considered as a small magnet having a resultant permanent magnetic moment. On the basis of this, we are able to classify the substances into 5 different parts. Number 1, paramagnetic substances. The substances which are attracted by the external magnetic field are called paramagnetic. The property thus exhibited is called paramagnetism. This property is shown by the substances whose atom ion molecule contain unpaired electrons. Example O2, Cu plus 2, Fe plus 3, Cr plus 3. These substances, however, lose their magnetic properties in the absence of magnetic field. Second is diamagnetic substances. The substances which are weakly repelled by the external magnetic field are called diamagnetic substances. TiO2, H2, NaCl, benzene are the examples of diamagnetic substances. The property thus exhibited is called diamagnetism. This property is shown only by those substances which contain fully filled orbitals and no unpaired electrons are present in them. Third is ferromagnetism. A substance which show permanent magnetism even in the absence of the magnetic field are called ferromagnetic substances. Iron, nickel, cobalt, gadolinium show the ferromagnetism. Such substances remain permanently magnetized once they have been magnetized. These substances are very strongly attracted by the magnetic field. The reason for such magnetic behavior by these substances is that in the solid state, the metal ion of these substances are grouped together into the small region called domain. Each domain acts as a tiny magnet having a definite magnetic moment. Due to which they will have a strong permanent magnetic moments which are present or oriented in the direction of the magnetic field. And when external magnetic field is removed, they will remain in the same order. Therefore, these are the substances which are used for making high quality magnets. Antiferromagnetic substances. The substances which are expected to possess paramagnetism or ferromagnetism on the basis of magnetic moment of the domain, but actually they possess zero net magnetic moment are called antiferromagnetic substances. Example MnO. Antiferromagnetism is due to the presence of equal number of domain in the opposite directions. Ferromagnetic substances. The substances which are expected to possess large magnetism on the basis of the magnetic moment of a domain but actually have small net magnetic moment are called ferromagnetic substances. And the structures are given here. Number 1, the first structure that is given for ferromagnetic substance A. In case of B, we are having anti-ferromagnetic substance, while the structure C is representing for ferromagnetic substances. Now the classification of the solids on the basis of the electrical properties. We know that the substances are divided into 3 different parts. One is known as conductor, other is insulator, and third is semiconductor. Now what are conductors? The solid which have conductivity in the range of 10 to the power 4 to 10 to the power 7 ohm inverse, meter inverse are called conductors. While insulators are the solid which have extremely low conductivity, that is ranging between 10 to the power minus 20 to 10 to the power minus 10 ohm inverse meter inverse are called insulator. Example: plastic, wool, rubber, sulfur, phosphorus, etc. Semiconductors are the solid which have conductivity in between those of conductor and insulator, that is ranging from 10 to the power minus 6 to 10 to the power 4 ohm inverse, meter inverse are called semiconductors. Explanation of behavior of conductor, insulator and semiconductor on the basis of band theory. If the valence band is partially filled or it overlaps with the higher energy or unoccupied conduction band, then the electron can easily flow under the influence of an applied electric field. Hence, the metal conducts electricity, as we observed in the case of the first diagram. If the gap between the valence band and conduction band is small, some electrons may jump from valence band to the conduction band. Hence, the substances shows some conductivity and it acts as semiconductor, that we observed in the last diagram, where there is a small gap is present between the valence band and conduction band. While in case of insulators, a large energy gap is present between the valence band and conduction band. The top of the valence band and the bottom of the conduction band, this gap is known as energy gap or forbidden zone. If this energy gap is large, definitely the substance is insulator and does not allow the electric current to pass through them. Now there are the certain substances in which we observe that the electricity is generally produced only on heating a polar crystal. Then it is known as a pyroelectricity. Now when mechanical stress is applied on the polar crystal and electricity is produced due to the displacement of the ion, it is known as a piezoelectricity. Now there are the two ways by which the polar substances are able to generate the electricity. One by heating, which is known as pyroelectricity, and other by producing the mechanical stress or the strain over them, which is known as piezoelectricity. Semiconductors are of the two types, intrinsic semiconductor and extrinsic semiconductor. The pure substances that are semiconductor are known as intrinsic semiconductor. Here these substances like silicon, germanium, which are insulator at 0 Kelvin, but above 0 Kelvin they become semiconductor. Therefore we call them as intrinsic. While in case of extrinsic semiconductor, their conductivity is due to the presence of impurities. They are formed by doping. It is defined as the addition of impurities to the semiconductor to increase the conductivity. For example, in this case, the silicon and germanium, they are doped with either 15th group element or 13th group element to enhance their conductivity, which is known as extrinsic semiconductors. Now the application of N-type, P-type semiconductor. First application is a diode, which is a combination of P and N type of semiconductor, which is used as a rectifier. The solar cell is an ambient photodiode used for the conversion of light energy into electrical energy. Transistor are the sandwich semiconductors of the type PNP or NPN, which are used to detect or amplify the radio or audio signals. Gallium arsenide semiconductors have very fast response and have revolutionized to design the semiconductor devices. Now these are the questions which is given for the assignment from the chapter solid state, and it is also mentioned in your NCERT book. The first, how will you distinguish between the following pairs of the term: hexagonal, that is SCP close packing, and cubic close packing, crystal lattice, unit cell, tetrahedral void, octahedral void. How many lattice points are there? You have to determine face centered, tetragonal, and body centered. And you have to calculate the packing efficiency: simple centered cube, body centered cube, face centered cube. And you have to do this assignment in your homework notebook.